Welcome to my video on connecting resistors in series. So this is the case that we're looking at here is when we connect three resistors, going to be R1, R2, and R3 in series. In other words, they're back-to-back connections. The same current, I, flows through each resistor, and this is our voltage source. So we're going to use, first of all, we want to start looking at what we know about this circuit and then try to figure out the equivalent. So what we want to try to find out is we want to know R equivalent. In other words, the voltage, our voltage source there, V, R equivalent times I. So how do we figure out the equivalent resistance of those three resistors? 1, 2, 3. That's really what we're looking for. So what we're going to do is we're going to use Ohm's law first of all. We do know that. There was a video on that you can watch if you're not familiar with Ohm's law. V1 is equal to I times R1. That's the voltage drop across this first resistor. Now we're going to look at the voltage drop across this resistor, the voltage drop across this resistor. We're just applying Ohm's law. That's something we do know. And so V2 is equal to I times R2. And V3 is equal to I times R3. So that's just an application of Ohm's law. So now if we look across AB, we know that the voltage drop there is just the sum of the individual voltage drops, because the applied voltage of the EMF source there, they've got to be equal. And so we know that the sum of the voltages across each resistor is equal to the applied voltage. And we also know that this current times the equivalent resistance is equal to this voltage drop also. So what we can do is we can say IR equivalent is equal to I1 R1 plus I R2 plus I R3. All we've done is just taken this equation and substituted in these three values for the voltage drops. And so what we see is pretty obvious here is the I's all go away, which is handy. So R equivalent now is equal to R1 plus R2 plus R3. So that's the equivalent resistance for those three. Now we can generalize this and come up with a case where we have let's say we have N in series, a bunch of resistors in series. So the R equivalent now is we sum from I equal 1 to N, that's just a counter. I is equal to 1 to N, the total number of resistors, and we just sum the individual resistor values. So that's kind of our general equation for if we have a bunch of resistors in series, N resistors in series. Now let's look at an example. In this situation here, we're trying to find the equivalent resistance. We have three resistors. R1 is 1K ohm, R2 is 2K ohm, and R3 is 9K ohm, and they are connected in series. Now we want to find this equivalent resistance. So R equivalent, we know from our equation we just derived, R1 plus R2 plus R3. So R equivalent now, we just sum these resistor values. R1 is 1K ohm, R2 is 2K ohm, plus R3 is 9K ohm. So summing those together, that's going to be 1 plus 2 is 3 plus 9, that's 12K ohm. So our R equivalent, there's our answer, by summing those three resistors in series. Well, I hope you got something out of this video and learned a little bit about resistors in series. And if you did, give me a like, thumbs up, subscribe to my channel, and thank you for watching.